Welcome back to PV Online. Today we're going to take a look at how to solve a Newton's second law problem if you have two objects. And what we have here is we have two objects. We have mass m1 with the mass of 3 kilograms and mass 2 with the mass of 7 kilograms. And our task is going to be to find the acceleration and the tension inside that wire. We're going to have a massless, frictionless pulley, which is going to make our life a lot simpler. And to be honest with you, for the most part, it's going to be perfectly appropriate. We come over here, and the very first thing that we need to do is we need to do a force diagram. Now, we know that this guy has a mass of 3 kilograms and M2 has a mass of 7 kilograms. You do need to recognize which way this system is going to accelerate. And we know that M2 is bigger as far as the mass, so it's going to accelerate down. And while it's accelerating down, M1 is going to accelerate up. The reason this is going to be important is it's going to dictate what signs we give our forces. So let's go ahead and do the force diagram, and I'm going to have this guy has mg, as all objects do, but I'm going to call it m1g, and I do that because I have two objects. So make sure you put subscripts so you can indicate exactly which m you're referring to. This has a rope, so as soon as it has a rope, that means it has tension, and the tension is going to be directed straight up. It's always going to go away from the object. Those are the only forces acting on M1. It's not sitting on a table, so there's no normal. So let's go over here to M2, and M2 is going to have gravity, so it's M2G, and it's also going to have a tension. Now, since we have a massless, frictionless pulley, those tensions are going to be the same. And notice that both the tensions are going up because they're going away from the object. Okay, I've done the force diagram. I'm ready to start. And I start by writing the sum of the forces equals the mass times acceleration. And so let's just start with object 1 to begin with. I want you to make the force that's in the direction of the acceleration as positive. This guy is accelerating up, so we want the upward force as positive, making that tension positive. mg is acting down, so I'm going to make that minus m1g, and that's going to equal m1a. It's very important that you put those subscripts in there. I've got one equation, but I have two unknowns. And in your math class, whenever you have two unknowns, you know you have to have two equations. So I've taken care of everything I can solve for M1, so I'm going to take a look at my second object. Which force are we going to make positive? It's important that you make the force that's in the direction of the acceleration positive. M2 is accelerating down, therefore M2G is positive. So I'm going to make this M2G minus the tension, and that's going to equal M2A. Now the reason I don't have to call those A1 and A2 is because with our massless frictionless pulley, both of these objects are going to accelerate at the same rate. So both of the A's would be equal to each other. So I have two equations, two unknowns, and either you could do substitution or you could come over here and let's add the two equations. And the reason I want to add the two equations is because I know I don't have tension, I don't have acceleration, but mathematically, look what's going to happen to the tension. I've got a tension minus a tension. It's going to cancel out, leaving me with just M2G minus M1G equals M1A plus M2A. That tension is going to cancel out every time. Every time you do these problems, the tensions will cancel out. If they don't, you have a sign problem. So M2 we said was 7 kilograms, so I'm going to take 7 times 9.8 minus M1 has a mass of 3, so 3 times 9.8. And I always factor out the A, so that's going to give me 7 plus 3 times A. And we can solve for our acceleration, which gives us an acceleration of 3.2 meters per second squared. So block M2 is going to accelerate down at 3.92 meters per second squared. Block 1 is going to accelerate up at 3.92 meters per second squared. The second question asks for the tension. Well, it doesn't matter. Just pick one of these two equations. You can pick either one of these and let's solve for tension. Now that I know the acceleration, I'm going to take t minus m1, which we said was 3, times 9.8 equals m1 times 3.92. I solve for the tension and we get 41.2 newtons. And that will be the tension inside those ropes or strings. So we have another example, only this one we have a 2-block system, but there's going to be friction. As soon as you see more than one object, that means you're going to have more than one equation. So we're going to find the acceleration and the tension again. In order to do so, the first thing we want to do is do a force diagram. And I'm going to have m2g because gravity acts on everything. And tension always acts away from the object, so tension is going to act up. For block M1, the tension, the rope is going to be pulling the block to the right. It's going to have M1G, gravity is going to be acting on it. And it's going to have a normal force because it's sitting on a table. Now, which way will friction act on the block? The tension is going to make it accelerate to the right, meaning that friction is going to oppose it, so friction is going to act to the left. In order to get the signs right, we want to make sure we know the direction it's accelerating. Which way is the system accelerating? And I know that block M1 is going to accelerate to the right. M2 is going to accelerate down. Notice I'm not putting the arrows for the A on my force diagram. It's not a force. I start, as I always do, with the sum of the forces equals the mass times acceleration. And I know I can first do this one because it's kind of easy. This is the important part. Which force do I want to make positive? And I want to make m2g my positive force because it's in the direction of the acceleration. The block is accelerating down. That means m2g has to be larger. Tension's going in the opposite direction, so I'm going to make that minus tension. That will equal m2a. Let's go to the next block, and I have to go to the next block because I don't know tension, I don't know acceleration, I have two unknowns. So focus initially on what forces are acting in the direction of the acceleration. And while I have 4 forces on block M1, only tension and only friction are going to be affecting my sum of the forces in terms of the acceleration. So now which force do you want to make positive? And the acceleration is to the right, tension is to the right, so I'm going to make tension positive, minus friction, and that's going to equal m1a. Fortunately for us, look at what happens with the tension. They cancel out, and they will always cancel out. That gives me m2g minus friction equals m1 plus m2a. So I've got m2g minus friction, and we know that friction equals mu times the normal. And if I want to find out what the normal is, I look vertically, and I know that m1g and the normal are balanced, so that'll be m1g. That's going to equal m1 plus m2 times a. Let's start plugging in some numbers. So m2 had a value of 3 times 9.8. My mu was 0.2. M1 had a mass of 5 times 9.8 equals 3 plus 5 times my acceleration. I solve for my acceleration. I get 2.45 meters per second squared. For part B, we need to find the tension. Choose whichever equation you want. I'm going to choose the top one because it's just a little simpler. So I have m2g minus the tension equals m2a. And m2 is 3, so we have 3 times 9.8 minus the tension equals 3 times 2.45. So the amount of tension in that rope is going to be 22 newtons, 22.1 newtons. So there you go. We've dealt with when when you have friction and more than one object, and inclines. You should have everything to finish this unit. Good luck, and we'll see you next time.